Okay, so we're going to talk about probability and some of the basic concepts involved when we're talking about probability. Um, so anytime you're trying to calculate something, especially if it's very basic, where you have a number of equally likely outcomes, um, when you're trying to find the probability of an event, you basically just need to divide the events that are going to be favorable to whatever you're looking for divided by the total. So, you know, let's have an event E. So we have event E. The probability that event E occurs is going to be the number of outcomes favorable to E divided by the number of outcomes total, or in the sample space. So look at an instance where you're talking about, let's say, getting a heads, right? When you're flipping a coin, Well, the only outcome that's favorable to getting a heads is to get a head. And the number of outcomes total are going to be 2. So you would get 1/2. That's why a 50% likelihood is what you're going to get. Okay, so that being said, then we move on to this other very, very important concept when we talk about probability, and that is something called the law of large numbers. And basically what that means is what the law of large numbers says is if you carry out something over time, multiple times, the probability that you see is going to be pretty much exactly accurate to the theoretical. So what does that really mean in terms of a problem or something that you can understand? Well, think about flipping a coin. We know that the probability of getting a heads, okay, that is, you have 1 likelihood over 2, right? So it's a 50-50 chance of getting a heads. Well, that doesn't mean that you can't get 70% heads over a certain period of time, or 80%, or even 90%, or 100%. Technically it's possible to flip a coin 1,000,000 times and always get a head. But the law of large numbers says that the more you flip the coin, if you were to flip it 100 times, or 200, or 300, the true probability is going to be pretty close to what you see. So, in a sense, look at this scenario where you're flipping a coin, right? So we said that, the percentage of heads. So let's say we've got 0 all the way up to 100. Well, let's say, as we go along, this is what we're going to look at. So let's say we have toss number and our result. So let's say toss number 1, I have a head. Well, 100% of my tosses are heads. Let's say the second one is also a head. So I still am at 100%. Third one, say I'm at a head. Still at 100%. But let's say the fourth one. So, we're up here. The fourth one, let's say we get a tails. Well, the percentage of heads at this point has dropped to 75%. When I know that it's going to be somewhere around this line. And basically, what's going to happen is that the more and more I do this, because the true probability is going to be 50%, that I'm going to kind of somewhere get around this line. The more and more I do this, the closer and closer I get to 50%. Now, it's possible for a period of time for this to not work, but over time, the longer I do this, the closer to 50% I'm going to get. And that's what the law of large numbers is. It says if I do something a large number of times, it's going to approach what the theoretical is. So this being said, kind of like what we just talked about, the relative frequency approach is if I, let's say, do some sort of event a bunch of times, we're going to look at the relative frequency of that. So, if I were to find that after shooting, Shaq shoots or has shot, let's say 40,000 free throws. And made 20,000. Put simply, if we were to look at, the probability of him making one, we would say the probability of Shaq making a free throw, we would say, well, he's made 20,000 out of 40,000. And so that equals a half. Not really that far off what he actually does. But the relative frequency approach is if I just need to figure out the probability and I know this, and I'm not sure what the true probability is, we can look at, a relative frequency approach, which is just divide the number of times E happens, or the number of times something happens, divided by the total number of trials that you see. Now, fundamental properties of probability. Number one, your probability is going to be somewhere between 0 and 1. 1 being 100% and 0 being 0%. The second is going to be the probability that something happens in my sample is always going to be 100%. So this means that 100% of the things that could happen have to be in my sample size. That's just pretty simple. Number 3, if two events are disjoint, and we will talk about this a little bit later, if two events are disjoint, then the probability, so let's say if E and F are disjoint, meaning that they have nothing in common, then the probability of E or F happening is the probability of E plus the probability of F. So the simplest way I can say this is like events that are disjoint. Like let's say an even and an odd number. Let's say if we roll a die and we get either an even or an odd. Well, the chance that you get an even or odd, those are separate. You can't have both occur at the same time. So if we wanted to say, well, the chance that an even or an odd happens is going to be the probability of an even plus the probability of an odd. So that's if they have nothing in common. Number 4, basically, the probability of E plus the probability of, let's say, not E always has to add up to 1. So you can actually mess around with this equation quite a bit. So anytime we're looking for not E, it's 1 minus the probability of E. Things like that. So you can mess around with this equation a little bit, but this is a really important fundamental thing for us to know, is that our probability has to be some number between 0 and 1. It could include 0, it could be 1. The probability of everything that can occur always adds up to 1. And then we have this thing with disjoint sets where the probability of the union of the two of them is the sum. And finally, the probability of two things that are complements has to come up to make 1.